Yes, sir.
Hello.
Sir, please start.
Okay. Hello, student. Today we will discuss about the topic mathematical logics from paper first. Okay. In mathematical logics, we say about statements. Everyone know what is meant by statement. In English grammar, there are 4 types of sentences. Which type of sentences these sentences are? Assertive sentence, interrogative sentence, imperative sentence, and exclamatory sentences. From these 4 types of sentences, the sentences which are declarative means the complete meaningful statement is formed. Such a declarative sentences are called statements. Okay. Means in logic, first one we have to see statement. What is meant by statement? Statement is the declarative sentence which says it is either true or false. The statements which are declarative sentences which are either true or false. The example likes sun is rise from east. Everyone knows this is a declarative sentence. Simple sentence is called assertive. Such a sentences are called statement and its truth value is true. The another sentence in mathematics, suppose I say 3 is a even number. 3 is a even number. This sentence is also some declaration. What types of number is 3? This declaration it gives means it is a statement, but everyone knows 3 is a even number. No, it is a odd number. So the truth value of this statement is false. But the sentences which are interrogative means like a question, exclamatory, and imperative. Imperative means like request or order. Request or ordered. Such sentences are not a statement. The examples are of interrogative sentence is what is your name? Where are you going? What time now? Such sentences are interrogative sentence. These are not a statement. Like an exclamatory sentence, what a beautiful sight it is. What a beautiful sight it is. This is an exclamatory sentence. And request or order, please give me your pen. Such a type of sentence. Or close the door. This is the order. Please give me your pen. This is a request. The sentences which are imperative. This type of sentences are also not a statement. Means statement are those sentences which gives declaration. Means simple assertive sentence having one truth value, either true or false, but not both, such sentences are called statement. These sentences are called statement. Okay, and remaining three types of sentences, interrogative, exclamatory, and imperative, are not a statement. Okay. Now, some declarative sentences have both truth value. Some declarative sentences have both truth value. Like, it is pink in color. One sentence is like this. It is pink in color. It is pink in color. What is pink in color? Again, another question are in your mind. Okay. He is a doctor. He is a doctor. Another question is also occurs in your mind. Who is a doctor? Who is a doctor? One mathematical sentence is like this: x plus 5 is equal to 7. X plus 5 is equal to 7. Which number plus 5 is equal to 7? This question is also occur in your mind. Means when we decide the value of x is equal to 1, then 1 plus 5 is equal to 7. No, means its truth value is false. But when x is equal to 2, 2 plus 5 is equal to 7, its truth value is true. Means any sentence we cannot decide its truth value, such sentences are called open sentence. Such sentences are called open sentence. Okay. Now again, statement. Statement is a declarative sentence which are either true or false, but not both. And statements are denoted by the small letter like P, Q, R, S, etc. etc. like this. And the remaining three types of sentences means interrogative, exclamatory, imperative. These are not a statement. These are simple sentences. But in a assertive sentence, some sentences are like this, which having both truth value at the same time. It is pink in color. It is pink in color. Doesn't know what is pink in color. If we show Spanish and we say it is pink in color, it's not possible. But when you show the rose, which is in pink in color, then its truth value is true. This mathematical sentence is also same. X plus 5 is equal to 7. It totally depends upon the value of x. Means it takes both truth value, either true or false. So such are not a statement. It is called open sentence. They are called open sentence. Now in logic, main part of logic is a connective. Main part of logic is a connective. When these simple statements are connected by some connective, then we get a compound statement. But what is meant by connective? How are they and which are the connective in logics? Everyone you know, there are 5 connectives in logics that we have to study whole year. These 5 connectives are which? The connective. Connective means it joins the two sentences. They are called connective, connection. Like the words which join the two sentences, these are called connectives. Then which are the connectives? There are 5 connectives in logics. These connectives are, first one is and, second one is or, Third one is not. Then fourth one is if then. And lastly, fifth one is if and only if. That if and only if is also called IWF if. IWF if shortly. These 5 words or a group of words, these words are called connectives in logic. And our whole chapter is totally depend upon these 5 connectives. Is totally depend upon these 5 connectives. The symbol of each connectives is also shown here. For and, we use the symbol like this, downward V. For or, V. For not, the symbol of similarity sign. For if then, forward arrow like this. And for if and only if, both arrow, forward and backward. Now, next point is compound statement. Compound statement. Compound statement means a sentence which is formed by using simple statement and these 5 connectives is called compound statement. The statement which is formed by the 2 simple statement and any one of these connective is called compound statement. When a compound statement is formed by using and connective, the name of that compound statement is conjunction. When a compound statement formed by using and connective, the name of compound statement is conjunction. The compound statement by using the or connective, the name of compound statement is disjunction. The compound statement by using the not connective, the name of such a compound statement is negation. And the name of compound statement which using the if then connective is called conditional. And lastly, when a compound statement is formed by using connective if and only if, it's called biconditional. For the conditional and biconditional, there are another name are also. These names are implication and double implication. The compound statement formed by using conjunction is shown by like this P and Q. P and Q. This is the symbolical form of compound statement conjunction, which is formed by the and connective. For example, 5 is a prime number and 7 divides 94. 5 is a prime number, means statement P, and 7 divides 94. This is the statement Q, second statement Q. The compound statement formed by the or connective is symbolically denoted by like this P or Q. The example of P or Q, suppose statement P, milk is white, statement Q, sky is blue. Then the compound statement formed of P or Q is milk is white or sky is blue. Milk is white or sky is blue. And this is the symbolical form of that compound statement. Negation is a one special type of connective which apply on a single statement only. Remaining these four connectives are applied on a two different statement, but negation is a special type of connective which apply on a single statement. Single statement, milk is white, milk is not white, like this negation P. It is also called Daniel of a statement. Daniel of statement. This is the mathematical word Daniel for negation. Daniel of a statement, write the Daniel of statement. One statement is given. 0 is a complex number, suppose. Write the Daniel of a statement or write a negation of a statement. Like this, we have to ask in an exam. Then the Daniel of statement, 0 is a complex number, is 0 is not a complex number. 0 is not a complex number. And this negation is applied on a only single statement. Conditional statement. One example of symbolical form of conditional statement is like this. P implies Q. P implies Q. Suppose statement P, a student got first number from our school or from our college, and second statement, when he worked hard. Okay. Student gets success when he worked hard. Then what is the conditional statement? If student work hard, then he get success. If a student work hard, then he get a success. This is the conditional form of compound statement. The another conditional form, if there is rain, then match will be cancelled. If there is rain, then match will be cancelled. जर तिथे पाऊस झाला तर match काय होणार? Cancel होणार. This is the another conditional statement. Okay. Biconditional. The symbolical form of biconditional statement is like this. P double implies Q. P double implies Q. Okay. Means 5 types of connectives and or negation if then, if and only if. From these 5 connectives, we form 5 different types of compound statement: conjunction, disjunction, negation, conditional, and biconditional. Now we have to see the truth table and what are the rules of these connectives. The truth table for this compound statement. For two statement, there are 4 truth value always. When only 2 statements are there, then there are 4 truth values, and that 4 truth values are like always like this. In first column, first 2 true and second true, 2 are false. And in second column is for the second statement. Alternate true, false, true, false. Everyone learn the probability in 10th standard and also 11th. And everyone know when a coin toss, single coin toss, we get 2 possibilities, head and tail. Similarly, for a single statement, there are 2 possible values. One is true and other is false. And when there are two statements, then there are four possible values. Four possible values are like this. For the first statement, both true and then false. And for the second statement, true, false means true, 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 false, false, true, and false, false. These four possibilities are occur for two different statements. And from that, we write the truth table for each connectives P and Q, P or Q, P implies Q, and P double implies Q. And for negation, I already said the negation is only one connective which apply on a single statement. Now, what are the rules for conjunction, disjunction, implication, and double implication? The rule of conjunction is when the both statement is true, then true, otherwise false. The rule of conjunction is when both statement, the truth value of both statement is true, then true, otherwise false. The rule of disjunction is both statement is false, then false, otherwise true. Otherwise true. The rule for implication is very important. The rule of implication is very important because here order is also important in implication. But in conjunction and disjunction, it's not important. Order means you write P and Q or Q and P. Both are the same. If you write P or Q, Q or P, both are the same. But in implication, P implies Q doesn't meaning that Q implies P. Q implies P. Doesn't mean that. The rule of implication is. Now, rule of implication is when the first statement is true and the second statement is false, then the statement is false. Otherwise, in remaining cases, it is true. In remaining cases, it is true. Here, the remaining cases, it is false. In disjunction, remaining cases true. And in also implication, when first true, second false, then the implication is false. Otherwise, true. Otherwise, true. Now, double implication. The rule of double implication is very easy. When the both statement having same truth value, then it is true, otherwise false. And everyone know negation. Negation for true, it is false, and false, it is true. Now, which type of question asked in examination over this truth table? या ट्रूथ टेबलवर कोणत्या प्रकारचे क्वेश्चन एमसीक्यूज मध्ये विचारले जातात? There are three different types of question asked in examination over this truth table. One is we have to give any one statement, any statement P and negation Q, like this, or P and negation P, like this. Any statement we have to give one. And for that statement, the options are given. What are the truth values for the given statement? What are the truth values? Truth values means last column. What are the truth values for given statement? The second question asks, which type of statement it is, either tautology, contradiction, or contingency. Now I will tell you what is meant by tautology, what is meant by contradiction, and what is meant by contingency. And third question is asked, we have to given two compound statement and ask, show or these compound statements are equivalent or not. These compound statements are equivalent or not. Equivalent means they are equal both or not. Now I will say you what is meant by tautology. Tautology means what? For any compound statement, the last column of truth table is true. Such a compound statement are called tautology. For any compound statement, the truth table of compound statement is true, then it is called tautology. We have to give one statement, any statement, it is either tautology or not, that we have to identify. Suppose a statement is given like this, P and Q, and negation P or negation Q. P and Q and negation P or negation Q. Which type of statement it is? Either tautology or contradiction. Option we have to give one. First option is tautology. Second option is contradiction. Third option is neither tautology nor contradiction. And fourth option is both statements are equivalent. Like this we have to give one. Both statements are equivalent. Tautology means when the last column entries in the last column are all entries in the last column are true, then such a statement pattern is called tautology. Contradiction means when the all entries in the last column are false, such a statement pattern is called contradiction. And contingency means when the entries in the columns are mixed, means it is neither tautology nor contradiction, then it is called contingency. Then it is called contingency. For that, we have to simplify it, or by using laws, we identify which type of statement pattern. See here, the first statement P and Q as it is. For that second statement, we apply negation, means negation of P and Q. Negation of P and Q is equal to negation P or negation Q. And lastly, by complementary law मध्ये काय असतो? What is the complementary law? P and negation P is equal to false or contradiction. P and negation P is equal to false. False means contradiction. This is the law of complementary. Complementary law we have to apply there. Now next point in our logic, after the truth table, tautology, contradiction and contingency, some quantifiers are there. Some quantifiers. How many types of quantifier in logics? There are two types of quantifier in logics. One is universal quantifier, which is symbolically shows like this. A in up direction, ulta म्हणजे ulta A. For all, it's called for all or every. The second quantifier is existential. The symbol of existential quantifier is like this. It's called there exist. Or some. Now, this quantifier, what say about themselves? The universal quantifier says the statement is true everywhere in the world, or the statement is true for all the given condition. The statement is true for all the given condition. Which statement are true for everywhere or for given condition? They are always true. Like the sun is rise from east. This is the universal truth. But another statement is like this. For all n belongs to natural number, n plus 5 is equal to 11. It's not true for every natural number. It's not true for every natural number. So such a statement are false statement. Such a statement are false statement. N plus 5 is equal to 11 is true for only one natural number, and that is 6. It is not true for all natural numbers. So such a statement are the false statement. Such a statement are the false statement. When it is true, when the condition is like this, n plus 2 is greater than 1. If the condition is like this, n plus 2 is greater than 1 for all natural number, then it is true everywhere in their set, in their condition. This is about the universal quantifier. The second quantifier is existential quantifier. Existential, there exists some. Some means at least one element the given condition, given statement is true. At least one. Like this. There exists n belongs to n such that n plus 5 is equal to 1, and it is true for at least one natural number, which is n plus 5 is equal to 11, means 6 plus 5 is equal to 11, which is the true statement. Which is the true statement. So these two are the quantifiers. One is a universal quantifier, other is the existential quantifier. Universal quantifier means it is true everywhere for all elements of the set. Existential quantifier means it is true for some or only one, at least one, kamit kami ek. It is not for all, but it is true for at least one, kamit kami ekala tari to true asla pahiजे, then it's called existential quantifier. After the quantifier, the next part of our logic is duality. Duality. What is the meaning of dual? Dual is a statement which obtain from the given statement by replacing the symbol and by or, the symbol T by C, and vice versa. Vice versa, reverse, or by and, C by T. Then we say the statement is a dual of given statement. For example, we have to given one statement, negation P and negation Q, or T imply or T or R. Write the dual of statement. What is the dual of statement? Our question is, what is the dual of statement? The dual of statement is replace and by or by and, T by C, again or by and. This is the dual of statement. This is the dual of statement. It's called duality. Means in the given statement, when we replace and by or, T by C, and vice versa means in reverse order, then we get dual of that statement. After duality, the next part is negation. Negation of compound statement. We know 5 types of compound statement: conjunction, disjunction, negation, implication, and double implication. For each compound statement, its negation, and the negation of compound statement is like this. See, first one is negation of conjunction. Conjunction P and Q. The negation of conjunction is equal to the negation of statement P and is converted into or, and the negation of statement Q. In sentence, we say the negation of conjunction is equal to disjunction of their negation. Disjunction of their negation. This is the negation of compound statement conjunction. Second one is negation of disjunction. The negation of disjunction is conjunction of their negation. Both are opposite of each other. And is converted to or, and or is converted to and. It's called negation of conjunction and disjunction. It is also called De Morgan's law. It is also called De Morgan's law in logic. Okay. Third one, negation of a statement is equal to statement itself. Negation of any negation statement is equal to statement itself. It is behave in algebra like when you take 2 times minus. In algebra, when you take 2 times negative, minus become plus. In the same way, negation of negation is equal to statement itself. Negation of negation is equal to statement itself. After that, fourth one, negation of implication. Implication साठी, conditional साठी, the truth table of conditional is important. The negation of conditional is important. And also from the conditional statement, we write converse, inverse, and contrapositive. So the conditional is important statement in mathematical logic. The negation of conditional statement is like this: the first statement as it is and negation of second statement. This first statement as it is and negation of second statement. The question in MCQ is also asked, one conditional statement is given and write the negation of that conditional statement. Or any one statement is given like this and we say write the negation of given statement. Write the negation of given statement. Write the negation of given statement. And for writing the negation of given statement, we know these laws or this rule of negation. Negation of conjunction is equal to disjunction of their negation. Negation of disjunction is equal to conjunction of their negation. Negation of negation is equal to statement itself. Negation of conditional is equal to first statement and negation of second statement. And lastly, fifth one, negation of biconditional. The negation of biconditional is, when you write direct answer, then it will be like this, P and negation Q or Q and negation P. This is the direct answer for the negation of double implication, but it got by taking three different steps. These steps are like this: negation as it is, implication. Implication is double implication is biconditional case, which write like this: P implies Q and Q implies P. First goes P implies Q, secondly Q implies P. Now we apply the negation of conjunction here. When you take the negation of conjunction, it will be goes disjunction, means like this, negation of first statement for and, it becomes or, negation of second statement, and lastly third step is this, negation of implication, first statement as it is and the negation of second, or here is also first statement as it is and negation of second statement. In this way, the negation of compound statement we apply there, and any question which asked on the negation of compound statement, we write the answer by using these laws, this rule of negation. After that, for the conditional statement, write converse, inverse, and contrapositive. Of conditional statement. Conditional statement. Converse, inverse, and contrapositive of conditional statement P implies Q is. For the P implies Q, converse is like this, Q implies P. In 9th and 10th standard, in geometry, you have learned different theorem. Different theorem like BPT, basic proportionality theorem. What is the statement of basic proportionality theorem? When a line in a triangle, a line is parallel to one side of triangle, then it bisects the remaining two sides in proportion. Then it bisects remaining two sides in proportion. And what is the converse of BPT? Converse of BPT, if a line which bisect any two sides of a triangle, then it parallel to third side of a triangle. Then it parallel to third side of triangle. Means in our first statement, we have to give a line is parallel, then it bisect. But in our second statement, converse, in converse statement, the line bisect two sides of triangle, then it is parallel to third side of triangle. Similarly, the converse of P implies Q is Q implies P. Now, inverse of Q implies P is negation P implies negation Q. This is the inverse of conditional statement. And contrapositive statement for P implies Q is, it is a converse of inverse statement, means negation Q implies negation P. These four types of statement are also conditional statement. Conditional statement means it is formed by using connective if then. It is formed by using connective if then. And all these four statements are conditional. One another question is asked. There is a relation between these four statements. What is the relation between these four statements? See, P implies Q is equivalent with negation Q implies negation P, and Q implies P is equivalent with negation P implies negation Q. Means given statement and its contrapositive both are the equivalent same statement, and converse statement and inverse statement are also logically equivalent. So the question asked like this: one question statement is given, one statement is given, it is either given conditional statement, converse statement, inverse or contrapositive, any one, and remaining three given in option, and you have to ask which is, and we have to ask which is statement, which two statements are equivalent, which two statements are equivalent statement. Okay, then which two statements are equivalent? For that, if you know this result, given statement and contrapositive statement are equivalent, converse and inverse statement are equivalent, then from this result you identify from the given statement which two statements are equivalent, which two statements are equivalent. Okay. After converse, inverse and contrapositive, the another part is here from this chapter is laws of logic. Laws of logic. There are 10 different laws of logics. 10 different laws. These laws are, see, these are the laws of logics. Idempotent law. Idempotent law means the law which explain on statement itself, P and P is equal to P. Q or P or P is equal to P. Means when a statement is combined with itself by and or connective, then a law is formed. It's called idempotent. After that, commutative law. Commutative law, P and Q is equal to Q and P. Means statement, if you change, then the value of statement is not changed. When the place of statement is changed, then the value of statement is not changed. Such a law is called commutative law. For algebra 2 plus 3 or 3 plus 2, the answer is always 5. In the same way, if you write P and Q, or Q and P, the answer is always same. It's called commutative law. Associative law. The associative law is explained on a three statement. The associative law is explained on a three statement like this: P and Q and R. In this three statement, there is no bracket. Then which two statement combine first and which statement combine next? That we have to decide. Here we take any two statement, P and Q first and then R, or we have to combine Q and R first and then P. And then P. Means you combine first two statement and then third statement, or you combine last two statement and then statement one.